Ladies and gentlemen, welcome to my second episode on mathematicians' greatest mistakes. Episode 1 of this series showed Einstein's gravity field equations were only approximations that solved for the difference between his theory and Newton's gravity. It also derived the full gravitational field equations for Einstein's gravity and the exact equations for gravity. This episode shows how that exact gravity solution blows up the Big Bang theory. It explains how an infinite steady-state universe fits astronomers' observations much better. By the early 20th century, astronomers knew the universe was much larger than our own Milky Way. They had observed other island universes, now called galaxies. Being unable to solve the mystique of Einstein's gravity, the only gravity equations they had were Newton's gravity and the Schwarzschild metric. The use of Newton's gravity played a big role in the development of the Big Bang theory. The main use of the Schwarzschild metric was to say that many observations of unknown origin could be due to black holes. And without these equations, they were working in the dark. First thoughts were that the universe was infinite and steady state. Problems were soon realized. In his shell theorem, Newton indicated the gravitational field of a body of uniform mass distribution could be treated as if gravity originated at the center of mass. Laplace and Poisson extended that to a uniform mass distribution of particles, making it entirely useful in the studies of the universe. So within the vast universe, any point can be regarded as the origins of gravity of a theoretical sphere of any radius. The mass m of galaxies in radius r is given by m equals 4/3 pi r cubed rho, where rho is the density. Newton's gravitational attraction, just gn equals gm over r squared. Inserting m gives gn equals 4/3 pi r cubed rho g over r squared. Reducing the r's gives a single r on top, so as r tends to infinity, Newton's gravity tends to infinity, and thus, under Newton's gravity, an infinite steady-state universe will collapse. But what happens when we use Einstein's gravity? Well, this is his gravity field equation, 4/3 pi r cubed rho g over 3r squared times 1 plus alpha, where alpha equals 2gm over c squared. When we insert that, we still have the r cubed over r squared, so that becomes r1, but we have here 1 plus an r cubed term over an r term, so this gives a single r distance in the top line and an r squared term in the bottom line. So as the radius, the distance tends to infinity, Einstein's gravity tends to 0. So under Einstein's gravity, an infinite steady-state universe will not collapse. Before we follow the mathematician's trail, it's worth looking at what the universe would look like under the redshift metric and the Schwarzschild metric. Under the redshift gravity, you have gr equals gm over r squared e to the alpha over r. Inserting alpha again gives you a term with an r cubed on the top and an r squared on the bottom, and then you have an exponential of an r squared term, because the r on the bottom diminishes that to r squared. So as r tends to infinity, gr tends to 0, and quite rapidly. So an infinite steady-state universe will not collapse. Under the Schwarzschild metric, we have gs equals gm over r squared 1 minus alpha over r. That becomes this term where you can see that although there is an r squared, it's subtracted away. So when 8 pi g r squared rho equals c squared, ds equals infinity. Using rho equals 10 to the minus 26 kilograms per meter cubed, which is about the density of the universe, gives gs equals infinity at r equals 10 to the 10th light years. So under the accepted Schwarzschild solution, an infinite steady-state universe would have long ago collapsed into centers of about 2 times 10 to the 10th light years apart. Or under the Big Bang theory, it had happened more recently, and we should be seeing photons from distant galaxies being blue shifted. Neither of these events has occurred. Look, just forget the Schwarzschild metric. It has nothing going for it. It was calculated by people who could not understand the simple approximations Einstein said he made. There is no physics to support it. It predicts orbital regression when only orbital precession has been observed. Predicts the universe can't exist. Had mathematicians worked that out, they should have realized something was wrong. They could have avoided their biggest mistake. They didn't. It is worse than that. Mathematicians and mathematical physics have been working for decades using mathematics without knowing its physical basis. That is another big no, never in the real physical world. It is a huge contributor to their greatest mistake. Mathematics does not make things happen. Perhaps they thought because Einstein said he used purely mathematics approach to obtain valid results, they could do the same. However, their collective efforts have resulted in their needing 24 times 10 to the 60 times as much mass energy as astronomers observe to explain their observations. I'm not sure if Einstein was aware that the solution to his field equations predicted that his gravity was weaker than inverse square in such a way that an infinite steady-state universe would not collapse. In any event, this extract from his 1917 paper on cosmological considerations shows he considered only a finite universe. Such a universe will collapse under any gravity theory. He introduced his cosmological constant to prevent that from happening. In 1929, Edwin Hubble observed that the more distant galaxies were, the greater was the redshift of photons from them. That caused Einstein to admit his cosmological constant was the biggest blunder of his otherwise great career. That was the start of the Big Bang theory. The Belgian priest Lemaitre is credited as being the first person to suggest the universe started from a primitive atom. The issue of black holes is only a minor irritation in the overall scheme of mathematicians' greatest mistakes. The Big Bang theory has its detractors, but its supporters insist they have the mathematics and observation on their side. It is hard to argue against maths that nobody understands. It persists because observations, as proponents say, can only be explained by an expanding universe theory. Under that theory, these features keep recurring. Gravity is only attractive, so an infinite steady-state universe would collapse. The observed photon redshift increasing with distance has no other valid explanation. All tired light theories, their possibility proposed by Zwicky, were debunked. Tired light explanations could not explain the observed time dilation of type 1a supernovae that increased linearly with redshift. A mechanism for slowing light requires scattering by particles, which would blur distant images. Tired light theories could not explain the observed cosmic microwave background radiation. Tired light from a steady-state universe could not pass the Tolman test. In an infinite universe, all the hydrogen would have long since fused to helium and there would be none left for stars to fuse. Entropy always increases. After infinite time, the universe should have infinite entropy and died a heat death. Element abundances are approximately the same as calculated from Big Bang nucleosynthesis. It is time to consider each of these in turn. Gravity is only attractive, so an infinite steady-state universe would collapse. Well, as was shown earlier and repeated here, an infinite steady-state universe will collapse under Newtonian gravity. Einstein's gravity showed that as r tends to infinity, gr tends to 0, an infinite steady-state universe will not collapse. The same occurs under the redshift gravity equation. R tends to infinity, gr tends to 0. All evidence is that the redshift gravity gr applies in all situations, so an infinite steady-state universe will not collapse. So to show how this works, I'm going to use this illustration. It consists of these circles representing, let's say, a visible universe of, say, a radius of 10 to the 10th light years, where X in the middle of visible universe A. Newton's shell theorem applies to all forms of gravity. The strength of gravitational attraction at the boundaries of this, under the redshift gravity, will be about 5 times 10 to the minus 12 meters per second squared. As that goes out, it gets larger, 10 to the minus 13, 10 to the minus 15, approximately 10 to the minus 18 meters per second squared. Now, to show what is happening, we'll just consider that visible universes D and E have no gravitational attraction on each other. So our visible universe A would attract C and B towards it. However, infinite universe E will attract C towards it, and the same as D will attract B towards it as well. So that prevents those collapsing in on A. This effect goes in all 3 dimensions and forever in an infinite universe. The same effect occurs under Einstein's gravity as well. So the infinite universe will not collapse under gravity. That ends the requirement for the 10 to the 60 parallel universes in any dimensions. That's it. End of story. No further argument should be considered. The next point is the observed photon redshift increasing with distance had no other valid explanation. All tired light theories, their possibility proposed by Zwicky, were debunked. Over the decades, dozens of theories have been proposed for its origins. Marmot evaluated all he could and found none were valid. But it has been known for some time that most detected cosmic rays originate within our galaxy. It was explained as them being slowed down by the intergalactic cosmic microwave background photons. Something similar to photons, but far more numerous, are cosmological neutrinos. If you have a look at those figures, they are very large compared to these. They have a rest mass of about 10 to the minus 4 eV per c squared, and that actually shows up, that's 10 to the minus 6, 10 to the minus 3, that's about 10 to the minus 4. Several other experimental observations that indicate neutrinos have a rest mass of about 10 to the minus 4 eV c squared. And look, despite what the standard model doesn't tell us about about them. Neutrinos are rotating plane polarized photons with that rest mass of about 10 to the minus 4 eV per c squared. That gives them a diameter of a few millimeters and a temperature equivalent of about 1.5 degrees K compared to cosmic microwave background photons of about 2.7 degrees K. Being electromagnetic radiation, they have the same effect as that attributed to cosmic background photons. There are so many of them that they provide a continuum throughout the universe. That continuum provides space with a property called viscosity. It slows down objects according to their momentum p, but does not scatter them. If Marmot or others studied it, they would find the following. I won't go into the maths, just give the details. The momentum loss for things electromagnetic is given by delta P equals 1 plus h naught over c to the d minus 1, where h naught is Hubble's constant and d is distance. Photons are constant velocity particles. Their speed is determined by the electric permittivity of matter-free space. That means their momentum loss becomes their redshift. So photon redshift is given by z equals 1.0000715 to the d minus 1. D is distance in million light years. The H naught and D figures come from the work of Friedmann. As an approximate guide, a photon has to travel through about 10 to the 27 neutrinos for each million light years it travels through intergalactic space. That causes it to lose 0.00715% of its starting momentum. That is not considered excessive. It will be shown later that it is supported by other observations. So the greater the distance photons travel, the greater will be their redshift. With no scattering, it has all the properties needed to explain observed photon effects. This equation was used to calculate the viscosity versus redshift under the mechanism just described. It gives this V curve. Superimposed upon it is the Doppler redshift curve. They're about the same up to redshift around about 0.8 on this scale. But the thing to note, redshift 5, it's about 12.2 billion light years. Here you're talking about 25 billion light years. So no matter how far telescopes peer into space, they will always detect fully formed galaxy images. And you'll see here the Hubble Ultra Deep Field and Webb's first deep field images. They're all fully formed. Rather than reconsider their options, mathematicians try to use more maths to explain what should now be obvious. The universe is infinite. They keep scrambling for new equations to match new observations. All the scrambling in the world won't match with physical observations. It has only succeeded in compounding their greatest mistakes. So these images are strong indications the viscosity redshift theory is real. More on that later. This neutrino viscosity effect on photon redshift is supported, not debunked, by observations. Next we come to tired light theories could not explain the observed time dilation of type 1a supernovae that increase linearly with redshift. Well, redshift depends upon the photon's momentum. Blue photons, energy 4 eV, have twice the momentum of red photons, energy 2 eV. Red photons will take longer to be redshifted through any value than blue photons. For z equals 1, they will be spread out over twice the time than for local SNE 1A spectra. And that's what Goldhaber et al. Observed. Next we come to a mechanism for slowing light requires scattering by particles which would blur distant objects. There were redshift proposals that involved photons being slowed down by interaction with intergalactic particles such as protons and electrons. That redshift mechanism could generate the observed redshift, but it would blur the images. Neutrinos are different. They are rotating plane polarized photons with rest dimensions of the order of a few millimeters. Their electromagnetic field is exceedingly weak. They exist in such huge numbers they provide a continuum in space that gives it the viscosity that redshifts photons, and it does that without scattering them. It will be shown later this viscosity effect is very real. Next we come to tired light theories could not explain the observed cosmic microwave background radiation. Well, in 1926, Eddington calculated the background temperature of space based on photon emissions as 3.18 degrees K. In 1933, Regner predicted it as 2.8 degrees K. Both were made for an infinite steady-state universe. Calculations from Big Bang proponents were between 5 degrees K and 28 degrees K, as long as we excluded Gamov's 50 degrees K in 1948. Later discovered by Penzias and Wilson in 1965 and measured as 2.718 degrees K, mathematicians modified their calculations to match their theory to observation. Cosmic wave background has nothing to do with the Big Bang and expanding universe theory. It is simply the background temperature of space associated with an infinite steady-state universe. It was calculated over 30 years before it was discovered. Then we come to tired light from a steady-state universe could not pass the Tolman test. Tolman was optimistic about the magnitude expected from receding galaxies and pessimistic about that from a steady-state universe. In any event, this mechanism passes the Tolman test, so that's not a problem. For the record, if we applied this equation to 1 GeV photons, the typical cosmic ray energy, we get this result. After traveling 10 to the 4 light years, which is pretty much local within a galaxy, they've only lost 0.5% of their momentum. By the time they've traveled 10 to the 5th light years, which is basically across a galaxy, they've lost 5% of their momentum. By the time they've traveled to the nearest galaxy, which is typically 10 to the 6th light years away, they've lost 30% of their momentum. And then by the time they've tossed the equivalent of 10 intergalactic distances, there's virtually nothing left. So this effect explains why very few cosmic rays originate from outside our galaxy. That is enough about the so-called tired light problems. The neutrino viscosity mechanism passes them all. I mentioned earlier I would have more to say on them later. That later is now. Calculations of Mercury's perihelion precession predict it would be 43 arcseconds per century. Measurements by Park et al. Show it is more like 41.8 arcseconds per century. It's difficult to be highly accurate because Mercury and Earth keep changing their position relative to each other and to the background stars. To explain what could slow down Mercury's orbital speed, we'll apply that same equation to a nucleon of mass 938 MeV per c squared and is traveling at Mercury's orbital speed. From that, we get a nucleon would be slowed down by about 1.6 arcseconds per century to about 41.4 arcseconds per century. Now, this effect applies equally to all Mercury's nucleons because they are all exposed equally to the same neutrino density. Neutrinos are ever present everywhere, penetrating empty space and mass equally. Cosmic microwave photons can't penetrate mass. They do not contribute to this effect. It slows Mercury's orbital precession from 43 arcseconds per century to 41.4 arcseconds per century. However, neutrinos have mass and will be attracted by the Sun's larger mass. The density of cosmological neutrinos would be less near the Sun than in intergalactic space. That would reduce the viscosity effect on Mercury, making it closer to the observed precession of about 41.8 arcseconds per century. That agreement is considered reasonable. It gives further indication of the existence of this effect. There are other observations that suggest this effect is very real. They are seen in these images of spiral arm galaxies. Feature they all have in common is that the spiral arms lag behind their galactic core's rotation direction. Many thousands of them have been imaged. Now, that is a clear indication there is something causing that lag. Suggestions that stars with masses of 10 to the 55 or 10 to the 60 nucleons could be slowed down by background photons or cosmic rays are just not realistic. That leaves neutrino viscosity as the most obvious explanation of that lag. It causes the reduction in Mercury's orbital precession, the slowing down of cosmic rays, and the redshift of photons from distant galaxies. Spiral arm rotation is slowed down by the nature of cosmic neutrinos, giving space its property called viscosity. This has shown the effect is very real, very large, and very universal. Next we come to, in an infinite universe, all the hydrogen would have long since fused to helium. There would be nothing left to fuse, and, point 8, entropy always increases. After infinite time, the universe should have infinite entropy and have died a heat death. Neither of these have happened. The reason is the same for both. Gravity reverses entropy. That is usually indicated to be wrong because of the second law of thermodynamics. And a quick question: which is more disordered? A large gas and dust cloud a few light years in diameter, or its collapsed form of the Sun and planets neatly orbiting in our solar system? Well, the mathematicians will say, well, that doesn't consider the bigger picture of photons emitted and the higher speeds of the hotter particles. It is they who are missing the bigger picture, which I will now show. To understand it, you must go back to the theory of gravity. This redshift gravity equation is the only one that predicts this shape because of the maxima at r equals half alpha. And there is very sound physical reasons for gravity to be strongest at radius of half alpha, which could be outside the radius of a massive body. And compare that to black holes. They have no physical reason for existing. Their mathematical reason is because mathematicians made multiple mistakes. Gravity is only attractive. For something as massive as the Sun, the Schwarzschild radius is about 3 kilometers in a physical radius of about 700,000 kilometers. The Schwarzschild radius increases linearly with mass, while the physical radius increases by the cube root of mass for the same material. With enough mass, a stage will be reached when the Schwarzschild radius is outside the physical radius. That would only occur for neutron stars. Now, the gravity inside neutron stars doesn't just attract protons, electrons, and neutrons. It also attracts photons and neutrinos, taking their entropy with them. Under the huge gravitational force, photons are incorporated into the mass of the neutrons. Neutrinos are absorbed when gravity forces an electron into a proton. That takes away 0.8 MeV energy for each conversion. Contrary to the mathematician's standard model, neutrons are not made up from quarks and gluons. They've never been detected anyway. They have a structure that can be compressed but will not collapse. It is one in which their magnetic poles will align in their direction of travel, and they also orient themselves so that the south pole of one is adjoined to the north pole of another. So all neutron stars rotate. Almost all neutrons will be aligned in such a fashion. When the diameter of a neutron star is many kilometers, the diameter of a neutron is about a femtometer. Neutrons adopt this structure. It provides a wonderfully strong structure throughout most of the neutron star. Everything is neatly ordered in the most condensed state possible. It is hard to visualize anything that has a lower energy per unit mass than a neutron star. That's the big picture of which mathematicians are unaware. Close to the center of a rotating neutron star can't get an ordered pattern. Around the central axis you have this weaker structure. Structure is of course weakest at the surface. As these gravity redshift curves show, gravity is stronger on the outside than on the inside. This means that the strong external gravity will be pulling the neutrons towards the outside, leaving the center somewhat less dense. A stage is reached where neutrons in the center are no longer being compressed by gravity. The electrons that were forced into protons to form neutrons are free to escape from neutrinos. They form hydrogen atoms which become molecules. Every time a neutron changes to a hydrogen atom, it releases 0.8 MeV energy. Passage of time sees more hydrogen gas produced. The pressure and temperature become so high, some fuse into other low Z nuclei like helium. But ultimately a stage is reached where the internal pressure is so high the gas breaks out at the weakest point, and that is the center of rotation of the neutron star. So out comes this narrow stream, mostly hydrogen, but a bit of helium and the occasional low Z metals. It is accompanied by lots of photons. As well as the high pressure, they are also accelerated by the gravity field being outside the star. Usually just one pole erupts and you get one jet, but occasionally both poles can break at once and you get two jets. Now each hydrogen atom that comes out is also accompanied by up to 0.8 MeV. That is a lot of energy to be released with particles and photons flowing out in a narrow beam through a long, narrow cylinder in the center of the neutron star. These objects are known as quasars. They both reverse entropy and change material primarily back to hydrogen. Their large number of nucleons means they can keep emitting particles and large amounts of energy from a long, small diameter cylinder for a very long time. The process from one quasar emission through gas and dust cloud condensation to form stars and planets that make their way through to the center of a galaxy to be cycled again may take hundreds of billions of Earth years. So what? An infinite universe has all the time in the universe. So that is how gravity reverses entropy and recycles matter back to hydrogen. That mechanism keeps the universe going forever. Cosmologists attribute quasars to an extra-large black hole swallowing up so much matter that very hot regions emit large amounts of energy. And that requires many improbable assumptions. This explanation is straightforward, no other assumptions required. Another feature is that the redshift is equal to e to the alpha over t 2d, which approximates to this, which means it has a mass in the top line. A large mass can give a high gravitational field. Quasars with observed high redshift do not mean they are distant objects that were features of the early universe. It means they can be massive objects that have a high gravitational redshift and are close. They are an integral part of the functioning infinite steady-state universe. Now we come to element abundances are approximately the same as calculated from Big Bang nuclear synthesis. Mathematical modelling of element formation after the Big Bang shows that there would only be enough energy density to fuse protons into helium and maybe the occasional lithium nucleus. That ratio would be about 88% hydrogen and 12% helium by atom numbers. Approximately the same numbers are found in cosmic rays and quasar emissions. They are the mechanisms by which matter is recycled in an infinite steady-state universe. That the great majority of the universe is composed of hydrogen and helium, with about 1% of it being made up of the heavier elements, is what is expected in an infinite steady-state universe. After that, there is nothing left for Big Bang theorists to hang on to. Their mathematics has nothing to support it from Einstein's work. The features they say could only originate from an expanding universe have been debunked. The Big Bang theory has many problems it can't explain. What was the nature of the infinitely dense singularity from which it started? Why is the universe's expansion so evenly balanced at 1 in 10 to the 60 probability? Why are fully formed galaxies still seen when the James Webb Telescope images were supposed to come from so close to what should have been the early universe? And there are many, many others. Surely it is time for mathematicians realize that a probability of 1 in 10 to the 60 chances of the universe existing equates physically to 0. There are those who would like to question the above findings because the neutrons and neutrinos were not as presented in the Standard Model paradigm. They insist the Standard Model is the most accurate model ever developed. Well, the Standard Model was developed by mathematicians. Its accuracy was confirmed by other mathematicians. An analysis of its physical meaning show it has far more physical unknowns than it has mathematical answers. The neutron and neutrino model are used as part of a model that describes the known stable particles, their properties. It shows how the structure of each particle is responsible for its properties such as mass, the special relativity corrections, electric charge, spin, chirality, and more. As presented earlier, it also solves many cosmological issues. This physical-based model works. People like Galileo, Newton, Faraday, Planck, Einstein, Dirac, Feynman, and others used mathematics and made great progress. The Big Bang and expanding universe theory was likewise based on mathematics. So why did it go so wrong? Well, Paul Dirac once wrote, "It is more important to have beauty in one's equation than to have them fit experiment, because the discrepancy may be due to minor features that are not properly taken into account and that will get cleared up with further developments of the theory. It seems that if one is working from a point of view of getting beauty in one's equations, and if one has really a sound insight, one is on a sure line of progress." A sound insight is an understanding of the physical principles that underpin the mathematics. It seems the mathematicians were too wrapped up in what they considered the beauty of Einstein's equations to worry about the physical principle upon which they were built. So collectively that has blown up the Big Bang theory. It was introduced because early mathematicians could not understand the simplicity of Einstein's gravity. The physical reality, as supported by the aforementioned physics and maths, is that the universe is infinite in space and time. In intergalactic space, those dimensions are Euclidean. The gravity of galactic, stellar and planetary masses changes that slightly when close to them. Occasionally they pass by a massive object to form an Einstein cross. Some may be deflected as they pass a massive object. Otherwise, they will travel vast distances in straight line through Euclidean space, and as shown before, as they make their way, they are simply redshifted. Beyond that, two effects prevent astronomers from seeing forever into space. One is the neutrino-introduced viscosity of space that slowly redshifts photons until they merge into the cosmic microwave background. The other is the collective gravity of galaxies when photons travel, say, 50 billion light years. It increases photon redshift beyond the viscosity reduction. Now, those who care about what is happening 50 billion light years away can calculate how much gravity contributes to photon redshift. It's not a difficult calculation. The infinite steady-state universe has a 100% chance of existing as observed. The next episode deals with the proposed dark energy and dark matter cosmologists need to explain astronomers' results.